All right, good morning. So this is day 3 of sequences and series. So we're gonna go ahead and get started with the do now like we usually do. So the notes once again are posted on Classroom for you to follow along. And then I'm gonna be doing it on my whiteboard on the bottom. Okay, so here's your do now for today. You can pause the video, work on it, and then replay it to go through it. But I'm just gonna go through it right now. All right, so let me kind of zoom in. Don't mind my dog in the background. Okay. So looking at the first one, we know we're looking for a sub 20, and they tell us a sub 1 is 15, so that means the first term is 15, and d is equal to -8, which means since we have a common difference, that is an arithmetic sequence. So we plug into the arithmetic formula. We've got our a sub 1 is 15, d is -8, and then it's n minus 1. Now, n, remember, is the number of terms. We're looking for a sub 20, which means we want the 20th term, so n is 20. So just plugging that in, we get a sub 20 is -137. Looking at the second question, there we know a sequence. And this term, it tells us that it's geometric. Well, if it's geometric, we need to find the R value, or the common ratio, which is a2 divided by a1. The second term is 2. The first term is 0.5 or 1/2. So we have 2 divided by 1/2, keep change, flip, and you get your R value is 4. So from writing the equation, we have to plug into the generic form right there. A sub 1 is 0.5. I just left it in, even though I don't like fractions as much, I don't like decimals as much. I left it in the decimal form because that's what was given. And then times the ratio, which was 4, and then to the n minus 1 power. The third one there, they give us a sub 4 is 5 and R is 6. Well, they tell us it's geometric, and also because they give us the R value, we know there's a common ratio, so it has to be geometric. So we're going to plug into that formula. Now, a sub n, we don't necessarily know what the last term is, but we know that a sub 4 is 5. Well, a sub n, we can rewrite that there, noticing that n would be equal to 4. So we know that a sub n is 5 then, is equal to a sub 1, which we're going to have to find out what the first term is, and then is equal to the R value, which was 6, and then to the n minus 1. Now, n, remember, is 4 because it's a sub 4. So we plug that in, and we're going to divide that out, and we get 5 over 216, which is our first term. So plugging that back into the generic form, we've got 5 over 216 times the common ratio to the n minus 1 power. All right, so now we're just going to keep going with the lesson for today. So I'm going to go back to my board now. You can just follow along in your notes, no more with my computer. And we've got this sequence right here. Sorry, I'm just trying to focus the camera a little better. So we have this sequence right here, and we're missing the middle terms. We're missing 4 middle terms in the center. We only have the first, and not necessarily the last, but something over here, because we know that obviously it's infinite because we see those dots there. So we're looking for, it says find the arithmetic means. So we're looking for the terms in the center, but they tell us it's arithmetic. Well, if that's the case, we have to plug into our arithmetic formula. So we know that that is a sub n is equal to a sub 1 plus d times n minus 1. So plugging in what we know, a sub n, remembers your last term. Well, the last term that we know here is 22, so we can sub that in, is equal to a sub 1, the first term, which is -8, plus d, which we have no idea what the common difference is. We're going to have to find that so we can figure out our next terms in the sequence. And then times n minus 1. Now, n we know. If a sub n is 22, I want to figure out, well, what number term is 22? So just count the numbers that you have. 1, 2, 3, 4, 5, 6. There are 6 numbers, or 22 is the 6th term, so 6 minus 1. And then you would solve that out. You know that you're obviously distributing. We've got -8 plus 6d minus d, and that's equal to 22. So when you perform these operations, we're adding the 8, combining our like terms. We have 30 is equal to 5d, and d is equal to 6. So the common difference there is 6. So that means you're going to be adding 6 each time to get to the next number. So if you wanted to figure out the answers here, remember, write them as what terms they are. So a sub 2 is -8 plus 6, which is -2. A sub 3, a sub 4, a sub 5, because we're looking for the 4 terms in the center. Just adding 6 each time. We've got 4, 10, and then 16. The next question that we have is find the 5 arithmetic means between negative 18 and 36. Well, we're kind of doing the exact same thing here, but this time I don't give you the sequence with the blanks, so we're going to have to write it out like that, or we really don't have to, but it's a little easier to look at it if it's a little bit more visual. So we know that negative 18 is the first term there, and we're looking for 5 in between. So 1, 2, 3, 4, 5, and then we have 36. Now it tells us in the question, if you're following along in the notes, that it is arithmetic. So we're going to plug into our arithmetic formula. So we have a sub n, a sub 1 plus d times n minus 1, just writing that out. A sub n, remember, is our last term. Well, the last term that we know here is 36. The first term is negative 18. D is what we're going to be looking for, and then times n minus 1. But I need to figure out, well, what term number is 36? So I'm going to add 1, 2, 3, 4, 5, 6, 7. 36 is my 7th term, so 7 minus 1. Distributing that out, we've got negative 18 plus 7d minus d is equal to 36. And then we can go ahead and simplify this. When we add and combine like terms, we have 54 is 6d, and d is equal to 9. So that means that the common difference is 9. So you're going to be adding 9 each time. So we are looking for now a sub 2, a sub 3, a sub 4, 5 and 6, a sub 5, and a sub 6, right? Just listing them out. We can't just fill in the blanks there. Tell me what term number they are. So you have negative 18 plus 9. We've got negative 9 plus 9 plus 9 plus 9 and plus 9. And that would be your list of answers there. Okay. Moving on to the next one, it says to find the first 3 terms of the arithmetic series, and they give us a couple of different things. They tell us a sub 1, let me write it out here, is 7. They tell us a sub n is 79, and they tell us s sub n is 430. Well, they're telling us a whole bunch of things. Since they give us s sub n is 430, that kind of tells you how you should begin this problem. The only formula that we know so far that has s sub n is the sum formula of your arithmetic, and they already tell us that it's arithmetic in the question. So we're going to write that formula out. S sub n is n times a1 plus an, and then all over 2. So let's plug in what we know. We know s sub n is 430. The n value, we don't necessarily know, right? I don't know what n is, so I'm going to leave that for now as n. A sub 1, the first term is 7, and a sub n, the last term is 79. So basically we're looking for, well, what number term is 79? Interesting. All over 2. So we can solve this out. I'm going to cross multiply there. We've got 860. Can you see this there? Yeah. 860 is equal to, we're going to combine my like terms. So I'm adding, we've got 86 n. And then when we divide that out, n is equal to 10. But that doesn't answer the question. The question says to find the first 3 terms. So that means I want a sub 1, a sub 2, and a sub 3. Now we only know a sub 1 is 7. I need to find the next 2. And the only way to do that is by finding the common difference. I need to be able to add 7 plus d. Well, I don't know what d is, but I know an extra piece of information. I know n now. So what I can do is I can plug back into the original arithmetic formula, the generic form. Let me write out that formula. A1 plus d times n minus 1. And we're going to plug in what we know. We know a sub n. A sub n is 79. We know a sub 1 is 7. Plus d is what we are looking for, and then plugging in 10 minus 1. So we found out, remember, that 79 is the 10th term. So you don't know, well, what's that common difference there? So when we solve that out, we've got 72 is equal to 9d, and then d is equal to 8. Well, the common difference is 8, so all I need to do here is add 8 each time. 7 plus 8, and then 15 plus 8. And those are your answers for this one. Okay. Moving on to the next one. Find the first 3 terms. So kind of a similar question. This time we're given s sub n is 120, n is 8, and a sub n is 36. So they give us different things this time. And we're still looking for the first 3 terms, and they do tell us it's arithmetic, right? Now, once again, I have the s sub n, so I know I need to use that formula. So s sub n is equal to n times a1 plus an, and then all over 2. Okay, so plugging in what we know, we've got 120 is equal to n, which is 8, times a1. This time I don't have a1, so I'm going to leave that as a1, and then an is 36 all over 2. And I'm going to solve this out so I can actually solve for an here, or a1 rather. So we're going to multiply by 2 to get rid of that fraction. We have 240 is equal to 8 times a1 plus 36. Now you can either distribute or not. I'm not going to distribute. I'm going to just divide out that 8. So I've got 30 is equal to a1 plus 36. And then subtracting that out, a1 is negative 6. Now a1 is negative 6. So we're looking for the first 3 terms. a1 is negative 6. A2 and A3 is what we need. Now remember, we need that common difference to figure out what the next terms are. And the only way to do that is to be plugging into that original arithmetic formula. A sub n is equal to a sub 1 plus d times n minus 1. So plugging in for that, we know a sub n, they already give us, is 36 is equal to negative 6 plus the common difference. Do we know that? I don't remember. No. So that's what we're looking for. And then times n minus 1. Now n, remember, is 8. So remember, a sub n, the last term, 36, is the 8th term. Interesting. So we want to know what the common difference there is. So solving this out, we get 42 is equal to 7d, and then d is equal to 6. So the common difference is 6, so we're going to be adding 6 each time. Negative 6 plus 6, 0 plus 6, and those are your 3 answers for this. Okay. So give me 1 second, just moving on to the next. So now we have a different type of problem. So now we're moving on to some geometric stuff. So we started with the geometric yesterday. We noticed that there was a new formula. I'm just going to clean off my board. We noticed that there was a new formula there. So we're going to be using that this time. So now we're looking for, the next question says, to find 3 geometric means between 2 and 1250. Okay. So 3 between 2 and 1250. Okay, so I'm going to set this up using the sequence of numbers just so it's a little bit more visual, but remember, you can do it without. So I know that my first number here is 2, and we're looking for 3 between. So 1, 2, 3, putting my blanks there, and then we've got 1250. Now, the question itself tells us that it is geometric. Well, if it's geometric, we have to use our geometric formula, right? So that's from yesterday. So we're going to pull that back up. We've got a sub n is equal to a sub 1 times r to the n minus 1 power. A little different. A sub n this time is 1250. A sub 1 is 2, and then times r. Now, the common ratio, we have no idea. That's what we're going to have to look for or solve for. So we're going to leave that as r. And then to the n minus 1 power. Now we can find n, the number term. What number term is 1250? 1, 2, 3, 4, 5. So I have 5 minus 1. So now let's solve for r. We're going to divide out the 2 there on either side, right? 625 is equal to r to the 4th. And then we have to remember how to obviously solve for r. We know we have to take the 4th root on either side. So it's the 4th root of 625, which is 5. But I wouldn't be 100% correct in saying that. Remember, anytime you have an even index, there are actually 2 answers. You have to account for the plus and the minus, so the positive as well as the negative answers. So notice that there are actually 2 solutions to this problem. One with the positive r value and then one with the negative r value. So let's go ahead and list them. So we're looking for A2, A3, and A4. Well, if A1 was 2, remember you're multiplying if it's geometric. So 2 times 5 is 10. 10 times 5, and then 50 times 5. So that's the first set of answers. The second set, though, now you're taking r if it's negative. So we have 2, a sub 1, times negative 5, which is negative 10. Negative 10 times negative 5, which is a positive 50, and 50 times negative 5, which is negative 250. You actually have 2 sets of solutions. You have to include both because we don't know specifically what is in the center of this sequence. Okay. We have one more example like this, and then we'll move on to the next type. So it says find 4 geometric means between, so we want 4 between 0.5 and 512. Okay, so for this one, once again, you should set up your sequence visually. I mean, once again, you don't really have to, but for me, it's helpful. I'm a very visual person, as you guys know already. So I like to see it out. So I'm going to write my list of numbers. We start off with 0.5 and we've got 4 in between. So 1, 2, 3, 4, and then 512 is my ending number that we know. Now, once again, this is geometric because the question says so. So we have to plug into the geometric formula. A sub n, the last term, is 512. My first term is 0.5 or 1/2, however you want to enter it. And I'm just going to keep it as the problem says, but whatever. And then times r, which we don't know, which is what we're going to have to find, times n minus 1. Now, 512 is the 1, 2, 3, 4, 5, 6th term. So we're going to plug in 6 minus 1. Solving that out, we're going to divide by 0.5 or really multiply by 2. So we've got 1024 is equal to r to the 5th. Now in this case, we have to take the 5th root of 1024. I'm not expecting you to know how to do that obviously in your head, so you can just calculate it for that piece. And we get r is equal to 4. Now that tells us something. Now it's not plus or minus because the index is odd, it's not even, so we just have a positive 4 there. So we're looking for, remember, the 4 geometric means. So we're looking for a sub 2, a sub 3, a sub 4, and a sub 5 this time. So we have 0.5 or 1/2 times 4. 1/2 of 4 is 2. 2 times 4, 8 times 4, and 32 times 4. And those would be your answers to this next one. Okay, so now the next piece, I'm just going to pan to the notes for 1 second, and then we'll get back to my board. So remember we had started with the sum of the arithmetic sequence. Well, now we can do a sum of a geometric sequence, but there is a different formula. So I'm just going to pan to my computer for 1 second. So this is the formula right here that's provided to you on the reference table of your regions. But if you notice, it has a sub 1 twice. And if that's your missing term or that what you're solving for, it's going to be a little bit more challenging to solve because technically you're missing it 2 times in your equation. So what I like to do is I like to factor that out. You notice that a sub 1 is in common, right? So when you factor it out, it looks like that. And it's actually a little easier to solve because you only have a sub 1 written once. So that's the first thing I do when I get my Regents exam is I factor that out. I look at my reference table. This way I don't have to remember to do that later on. All right, so now back to the questions. It says find the sum of the geometric series, and that's the stuff that's we're given. So we're just going to follow back in with our notes. I'm going to go back to my board. Let me just make that better. Okay, so a sub 1 equals 2, n equals 10, and r equals 3. So those are the values that we know for this problem. And we're going to plug into the formula. So the first thing, remember, is I do factor it out. So I've got s sub n is equal to a sub 1 times 1 minus r to the n, and then all over 1 minus r. All right, so I'm starting off basic here, just plugging in. S sub n, the sum that we're looking for, a sub 1 is 2, 1 minus 3 to the 10, and then all over 1 minus 3. And this is something you can just plug directly into your calculator. And the sum of the sequence, given that information, would be 59,048. Okay. The next one is a little bit more challenging because we don't necessarily know all the information that we need. So let me just clean off this board. And it's still a geometric, so we're using that geometric sum formula. Just give me a second. All right, so looking at this, I'm just going to rewrite my formula and what we have. So a sub 1 is 2,000. A sub n is 125, and then r is equal to 1/2. Okay, so that's the information that we know for this one. So the formula, since they tell us that it's geometric, I'm just going to rewrite it out. Factored version, of course, because it is a little bit easier to solve. All right, there we go. Now, based off of that, we have to plug in what we know. Okay, so let's start plugging along. We have, we're looking for the sum, remember, so we don't have S of n, but we do have a sub 1, so S of n is equal to 2,000 times 1 minus. R is 1/2. Now it's to the n power, but we don't know n. So what I do is I have to find n first. Well, if I want to find n first, we need to use another formula. We're going to use the other geometric formula. So I'm going to do that here for a second. We know that that formula is a sub n is equal to a sub 1 times r to the n minus 1. Let's do that to solve what we know. 125 is equal to 2,000 times 1/2, and then to the n minus 1 power, we're looking for n. Now remember, I want to know what number term is 125 in this sequence. So I solve this out. I'm going to divide by 2,000. You can put it in decimal or fraction form. I don't really care as much. And then we got 1/2 to the n minus 1. Now, you should remember how to do something like this. We are solving for an exponent, which means we have to change it to a log, right? So that's exponential when you change it to a log in order to evaluate. So you're going to use bay, log, the b stands for base. The base there is 1/2 of the a, the answer is 0.0625 is equal to the exponent of n minus 1. We know we need n by itself, so we're just going to add 1 to either side, and you plug that directly into your calculator. N is equal to 5 when you solve that out. So since n is equal to 5, we're going to plug that in to the equation for n, the sum equation that we were doing before, to the 5th. And then that's all over 1 minus 1/2. And all you do is you plug that into your calculator and you would get your sum. The sum of the numbers in this sequence are 3,875. There's one more question that we need to do. And this would be just a straight calculator question. I'm not going to expect you to sit there and plug in every number between those. So I will just show you how to do it in the calculator. So remember, this is the question that we're doing, the sum there. Oops, sorry, I'm just trying to focus that. Okay, so if we're plugging it into the calculator, remember you're gonna hit alpha, and then the buttons up top are those hidden windows. So if you hit alpha window and go to the second one, that gives you your sigma notation there, and we're gonna plug it in. Now remember, you plug in the variable as x, so x is equal to 3. Moving on with the right arrow, up top is 10. So we want the terms from the 3rd term to the 10th term, and we're looking for the sum of them if that is your given equation. So 4 times 2, and then raised to the x minus 1. Just make sure you change it to an x value. And there you go. That would be the answer to the last problem.